Okay, welcome everybody. I have a few brief announcements to make before we start the talk. We'd like to encourage everybody to stop by the sponsors area, which can be found in the expo channel of the platform. If you visit a sponsor page, there'll be people and resources there to talk about job opportunities, etc. Also, there's an open invite to the happy hour tonight at Punch Bowl Social in Arlington, Virginia. It's between 6 and 9 p.m. So we'd love to see anybody with the BSidesNoVA ticket there. The address is 4238 Wilson Boulevard. And finally, I'm excited to announce the next talk, My Pentest Toolbox by Octavio Paguaga. And you can use the chat window to the right to put any questions in. So we will have a Q&A session. So as the talk goes on, just fill those up. And I'm handing it over to Octavio. I think you're on mute, Octavio.
Thank you, Daniel. Thank you very much, Daniel, for the introduction. My name is Octavio Paguaga, and welcome to My Pentest Toolbox. Just to kind of give you a quick primer as to what we're going to talk about. This basically is the equivalent of going through my actual toolbox at home and looking at my channel locks, my pliers, my wrenches, my table saw, so on and so forth. We're going to go through the various tools that I use for pen tests, preparing for pen test, or some phase of the InfoSec offensive realm. So now that we have that, let's go into who am I a little bit more. Cool. So who am I? Most importantly, I'm a father. I have 2 kids. I have a daughter who's turning 3 years old in August, and then I have a small little son who's 7 months old. I am a senior security consultant for Trustwave Government Solutions. I've been working there for about 2 years. Great place to work at. I also remove cicadas after hours. We have a pool in our backyard, and our cicadas aren't strong swimmers apparently. Or I'm sorry, strong flyers or swimmers. So I end up having to pick up quite a few dead ones each day after work. So quick thanks to Steve Borsch. Steve Borsch is my boss at TGS. He's the principal security consultant. He's taught me a lot over the last 2 years. He goes on Twitter by Reverse Shell. He's big in the open source tooling world. You can find him on Hack the Planet Discord. You can also find him on the Bloodhound Slack channel, which is the 3rd bullet on the slide. Jimmy Bain also is on Twitter. He goes by Bohops. Him and I have crossed paths. We've worked together in some capacity, probably for the last 5, 6, 7 years, maybe even. But Jimmy's a really smart guy, a great guy to have in your back pocket for questions, and just all around good guy. The Bloodhound Slack channel. The Bloodhound Slack channel has been around for about 2 years. What I've found, it's a great resource for people who have questions at all. They talk about Bloodhound there, but they also have various channels for Kerberos, red teaming, and a variety of other topics. Everyone there is usually pretty eager to help and willing to help, which is awesome. And then last but not least, Patrick Young for the last minute image on the right-hand side. So we'll start off with the sexy stuff first. Greenshot, Flameshot. As pen testers, red teams, we have to have screenshots for everything. It's kind of the saying of screenshot or it didn't happen. So prior to learning that these tools existed, or even Snagit existed, I would go with Microsoft Paint. I'm sorry, I would hit print screen, go ahead and paste it in Microsoft Paint, and then I would modify my screenshot there. Having multiple screens means that I had to filter out quite a bit. One cool thing that Greenshot has is the ability to go ahead and select a region. So I can just select a particular region, and then I can go to copy clipboard, which is probably my #1 option. And then from there, I can paste it wherever I want to paste it at. I can paste it into Word, PowerPoint, OneNote, whatever I'm using to track my screenshots for this pen test. Another option I use quite a bit is simply save directly using preferred file output settings. I use this a lot when I have to record multiple steps. So like yesterday, for example, I was doing a multi-step ACL attack against a client, and I would hit a command, take a screenshot, hit a command, take a screenshot. So it's just really easy to do save directly to, and you have a collection there. I also use that option when I'm doing pen test of web applications. It bugs me beyond belief to not have a screenshots of the application when it comes time to the outbrief, because photos go so much further than actual words do. So it just helps a lot. One thing to clear up, I didn't cover, Greenshot is for Windows, Flameshot is for Linux. So just choose your tool accordingly. AMSI. So what we have here is someone who attempted to run a PowerShell script called invoke reflective PE injection.ps1. And then we see in red, which is pretty hard to read, so I'll read it out loud. The script contains malicious content and has been blocked by the antivirus software. What has blocked this script from running is called AMSI, or Anti-Malware Scanning Interface. So up until PowerShell 5, which came out about 2 years ago, there was no visibility whatsoever into PowerShell code. So it was possible to write a self-contained, let's say, Cobalt Strike Launcher in PowerShell, go ahead and run in PowerShell 2, 3, 4, hit enter, and it would bypass any AV because there was no integration with AV. That feature hadn't been built yet. With PowerShell 5 came out AMSI. What happens now is my same C2 launcher gets loaded into PowerShell 5, it gets decoded, all the code gets ready to go, but before it gets executed, it gets handed off to an AV product. Defender has AMSI integration, Sophos has AV integration, and I believe Cobalt Strike has their own, CrowdStrike has their own AMSI engine. And this gives the opportunity for these products to go ahead and give a yay or nay. Here's where AMSI.fail comes into. So for as long as we've had AMSI as a feature, we've had AMSI bypasses. I think the first one that I know of was by Matt Graber, and it fit into a small tweet. So it's pretty good. There's not big stuff. There's not the big stuff you see here. But AMSI.fail, in short, is a collection of AMSI bypasses, and it goes ahead and obfuscates them as well for you. So what you would do is if you find yourself in an environment or on a machine that's running PowerShell 5 or PowerShell 7, you would go ahead and you would go to AMSI.fail, copy and paste this code into your PowerShell window, and then from there, you would go ahead and launch PowerView or whatever tool set you wanted to run. I will say I've been using AMSI.fail for about 9 months, give or take, and I've had great luck until the last month. In the last month, the AMSI bypass did not work for Sophos caught it and Windows Defender caught it. But because it was worked for the prior 8 months before that, I went ahead and mentioned it into this presentation. So the next slide, we're going to get into the NTLMRelay portion of our talk. And the best way to do that, I want to go ahead and just break down the tools real quick before we jump into anything. So when you do NTLMRelay, in essence, what you're trying to do is you're trying to first encourage someone to talk to you. So I need somehow, some way to get into a conversation between a client and a server. So you use man-in-the-middle 6 and responder to go ahead and do that. Basically, it's my way of enticing a client to talk to me instead of the actual intended target. I would then use the NTLMRelayX tool to forward those credentials off to somewhere else. Where those clients are, depending on my use case. I can go ahead and forward it to an Nth workstation just fine, or I can also go ahead and forward it to an AD server. I find myself forwarding them more to an AD server because the ADs are the kings of the kingdom. It's kind of tells me the password policy, the number of users, everything I need to know. And ultimately, if I can take over an AD server and get DA, I have access to whatever I need. And then we're going to perform the action. So once we authenticate onto that machine, what's next? Are we going to try to trigger a Cobalt Strike payload? Are we going to try to run a different kind of a DCOM lateral persistence? What are we doing next? And then So here we have man-in-the-middle 6. Before we get into our first screenshot, man-in-the-middle 6 was written by a gentleman named Dirk John. The tool can be found on his GitHub page. The reason the problem that man-in-the-middle 6 creates is that since Windows Vista and Windows Server 2000, Windows has actually preferred IPv6 communication over IPv4, which means that despite system administrators' best intentions, there's this whole IPv6 communication going on in the back end. We've actually had cases where responder has been caught by an IDS of some sort, and we've moved over to IPv6 to man-in-the-middle 6, and we've gotten around that IDS because there is no visibility. So because Windows has now integrated IPv6 into their OS, it's actually not recommended to go ahead and disable IPv6 as a whole. What they recommend that we do is to simply configure the registry key at the very last line to prefer IPv4 over IPv6. And then once you do that, the attack you're going to see in the next slide is impossible. So before we dig into the command, I'll kind of walk you through how I use man-in-the-middle 6. So the use case is as follows. We've shipped our client a small portable computer. They plugged it into their environment, and we don't know anything about their environment whatsoever. So we'd go ahead and power on man-in-the-middle 6 without any flags. You know, no TAC-D, no TAC-HW, none of that. Just go ahead and power on man-in-the-middle 6. And we'd start seeing the traffic. First of all, it would tell us if IPv6 is being used at all, because this attack might not even work. But secondly, it tells us which domains are being communicated with. So as we start convincing clients to request an IP from us, we can figure out where they're communicating to. They're communicating to, let's say, Google, Facebook, and then we'll figure out eventually what their domain name is. And in this case, their domain name happens to be TACD internal.corp. So we'd go ahead and hit Control-C. We'd run man-in-the-middle 6, this time with the TACD flag for internal.corp, and we'd run again. The reason why we use a TACD flag is simply because man-in-the-middle 6 can go ahead and bring down, can DOS an environment. We can make it so it's not possible to reach resources. So be cautious of that, just like you can with the good old-fashioned layer 2 ARPA man-in-the-middles. You can bring down networks. With with man-in-the-middle 6, you can bring down networks. So we go ahead and do our filter for internal.corp, and then after we'll call it 5 minutes for sake of discussion, we see that we've assigned host icorp TACW10 a IPv6 address. So now they're communicating to IPv6. And then shortly thereafter, we see that they went ahead and did a request for wpad.internal.corp, and also attacker TACWPad.internal.corp. So what have we done up to this point? So at this point, we have a client on the left who's trying to talk to the right. We'll say just WPAD. But because we've went ahead and launched man-in-the-middle 6, we've now interjected ourselves into the communication. So the client is now talking to us because of man-in-the-middle 6, and because we have NTLMRelay X on our machine as well. Once that client provides their credentials for, let's say, their WPAD for their proxy server, we can go ahead and then forward that off somewhere else. We can forward that off to, like I said earlier, a workstation and gain access to a workstation that they might have permissions to. Or even more lucrative for us as the pen tester is that we can go ahead and forward that off to an Active Directory server. Now, one of the big things that I like to use, I connect to an AD server for, is simply once you connect to, if you're able to authenticate to an AD server just fine, one of the first things that NTLMRelay X will do is it will go ahead and pull down the users, the groups, the password policy, the main trust, all into JSON and HTML files. All that's useful because it gives me a list of who are my DAs, how many users are in the environment, and also the password policy. Because if the password policy is 14 characters long, I'm not going to try to crack passwords. At least I'm not going to put too much effort into it. I might run them through a word list, one or two word lists that we have already set up, but I'm not going to go ahead and really spend too much time on it because it's 14 characters long. Other things we can do is what we see here, for example. So in the first green box, we see that we've authenticated to host 10.209.240.5 as user Octavio. So Octavio at some point has tried to authenticate to asset X, and this machine, because of man-in-the-middle 6, I've been redirected to the attacker box, and then from there, I've been forwarded to the NTLMRelay, to the AD server. And then in the green box, we see that there's been a computer account created. That computer account is SORBHUIW$, and the reason why I know it's a computer is because of the $. It's a denotation in AD for computers. And then we have credentials. The reason why this is possible is that there's a value in Active Directory called machine account quota, which by default is set to 10. And what that means is that it's possible for any user in the environment to create 10 computer accounts by default. So and that also opens up people to another clients to another attack, which is called role-based constrained delegation, which you won't get into, but it's very, very good and something cool. It's very useful and very fulfilling. So what we're doing here is we're going to go ahead and use the credentials that we've just created on our own, and we're going to run Bloodhound.py. So Bloodhound is a tool used for AD mapping, and that same gentleman, Dirk John, also went ahead and wrote a Python version of Bloodhound for use on a Linux machine. So we're using the computer account that we created with the password that we created to now run Bloodhound in the environment. And from there, we can grab users, groups, once again, ACL or access control entries, domain trust, local admins information, probably not local admins, but a variety of other feature information as well, without knowing a single password at this point. We've just went ahead and played middleman between a valid communication. So what have we done up to this point? Let's take a quick review. The review is we went ahead and used man-in-the-middle 6 to get involved into a communication between computer A and a server of some sort. When computer A authenticated to us, we went ahead and forwarded it off to a LDAP server, so an AD server using NTLMRelay. Once we authenticated to that host, to that AD server, we can create a computer account thanks to a AD attribute called machine account quota, which allows any user to create 10 computer accounts in a domain. And then from there, we ran Bloodhound. So we've done all this, just to reiterate, without knowing a single without knowing a single password. So how can this become more advantageous for us? We can also create user account. So let's go ahead and pretend that user Octavio is a help desk administrator, which I was at a previous life. So user Octavio is able to create user accounts because I have to manage my users in my environment. So user Octavio's credentials get captured, they get forwarded to the AD server, and NTLMRelay says, hey, you know what? This user can create a user account. Let's go ahead and create a user account. So that's what we see highlighted in blue. And that's the username right there in green. So we have a brand new user created called, and beginning with CKXP FB, 4 other characters. Even cooler is that because user Octavio happens to have some sort of access control entry over the internal.corp domain object, NTLMRelay is able to grant my user that we just created, the CKX user, get changes all permissions over the internal.corp domain. So what this means is that this user is now able to do a DC sync of all the credentials in the domain for the internal.corp customer. As far as how often this happens, this isn't very pie in the sky. I've actually had this happen to me twice in the last year. And the first time it happened, I was stunned. Like I just couldn't believe I went from having no access whatsoever to being able to do a DC sync. And if I didn't explain what a DC sync was, or if I did, I'm sorry to repeat myself. But in short, what a DC sync is, let's pretend we have a multi-domain environment. So we have 3 domain controllers. I changed my password on DC1. Well, we need a way for DC2 and DC3 to also have those passwords as well. So throughout the day, I'm not sure the exact interval, these servers all talk to each other. DC1 goes ahead and pushes down the ntds.did file, the database file, to the various DCs. And then that way, Octavio can authenticate to server 1, 2, or 3. Well, what also can happen is I can run a tool called secretdump. And with secretdump, I can say, hey, DC, user X is, this computer is also a DC. And I would like to pull down in this screenshot the credentials for Octavio_DADM. Apologies. Using, once again, the credential that we created. And then if we look at the 3 lines right here, we have the credentials stored in three different formats. We have it stored in NTLM or RC4, AES-256, and AES-128, and I'll explain why this matters in a few slides. So there are some rules to relaying to LDAP. So depending on what language or what protocol your AD server speaks, determines what functionality or what commands you can try to execute, or what are you trying to execute. So what I mean by that is, if you have an LDAP-S server, an AD server who has LDAP-S configured, meaning they have a certificate file, they talk over SSL, you can add a domain in a computer, and you can create a domain user and give DC sync rights. So in both screenshots, both of these past examples, if you would have noticed, it's always been LDAP-S of some sort. Now, if LDAP-S doesn't exist, I would recommend on the instance you're trying to talk to, I would recommend you find a different instance. But if you can't, because there's only one DC for whatever reason, or they all talk only in clear text, your options are now limited to only escalating the permissions of another user, of an existing user, pardon me. And if you take a step back, this is all pure luck. And the fact that I was able to get DA from NTLMRelay X was pure luck, in that I was able to capture the credentials for a DA while I was on their same subnet. So when you're stuck talking to only on the LDAP protocol, there's an extra layer of risk, of chance now, we'll call it. You have to not only have compromised the user account right now beforehand, but you also still need that DA. You still need to capture those DA's creds to be able to escalate that user to DA. So a little more work, but once again, if it pays off, that's phenomenal. So review of this, man in the middle 6 for redirection, NTLMRelay X to an LDAP-S server. A user was created that has DC sync privileges. So how can you defend against NTLM relaying? So first of all, when I say NTLM is not tied to SMB, as those two examples hopefully would have conveyed. NTLM is a SSP, which stands for Security Service Provider, give or take. It might be wrong, but the first word and the last word are definitely right. So what this means is that the environment's using NTLM for authentication. You can have Kerberos, you can have a CAC card, you could use 2 other options, which I'm unfamiliar with. But basically, this is the authentication scheme used by this domain happens to be NTLM. So you can use NTLM to authenticate to the SMB protocol, and you can use NTLM to authenticate to the LDAP protocol. So there's a feature for both protocols called signing, so SMB signing and LDAP signing. And when SMB signing, and I presume LDAP signing is enabled, there's basically a unique MIC field, which is that very last line in the with the red highlight. And there's this MIC, which is a message integrity code value. And this MIC is derived based on the communication between the client and the server. So we'll say between Daniel and the AD server. And the AD server is going to use a unique challenge key, which should only occur for that one client, and as well as Daniel's unique, I forget what it is, but basically the result is it's a unique MIC value. So if I was to interject myself between Daniel and the AD server and try to forward that somewhere else, that other server is going to say, hey, wait a minute, this MIC doesn't correspond to something that we've talked about. So I'm going to go ahead and drop it. This has been for SMB signing. And just another side story, we've did a pen test for TGS. TGS did a pen test back in August of last year, where this environment had SMB signing on every single machine but one. And the moment we found that, guess what one machine we went after? Because once we got onto that system, we were able to dump credentials. We were able to then move laterally onto other machines which had SMB signing configured. LDAP signing and LDAP channel binding are the security features that Microsoft has rolled out to basically prevent NTLM relaying to LDAP servers. So stepping away from NTLM relaying, I will say for full disclosure, Responder can do NTLM relaying. So I'm just choosing it not to cover it for this example because I have a particular example I want to talk about. So Responder is also a redirection tool. Responder will go ahead and take advantage of weak layer 2 protocols such as NetBIOS name servers, LLMNR, and MDNS to encourage users to talk to our computer. So I skipped over it, but if you recall on the Whoami slide, if you notice the big dog, that's my 135-pound dog burner, Milo. So what's happening here is someone is looking for a file share called Milo the burner. Milo the burner doesn't exist. So the computer is going to go ahead and try to resolve that computer name first by browsing through AD, or its local cache host file, pardon me, then looking through AD, and then it's going to shout on the network, hey, does anyone know where Milo the burner is? And it's going to resolve, it's configured, it's going to use those weak layer 2 protocols, so LLMNR or NetBIOS name server. And our server, our responder server is going to say, yes, I know exactly where Milo the burner is. Come with the IAM please authenticate to me. So what you see in that top window is you see in green, LLMNR poison answer sent to host 10.232.80.31 for name Milo the burner. That host ending in .31 has authenticated to our computer using NTLMV1. A couple minutes later, a couple hours later, whatever time frame, that same user authenticated to our system as NTLMV2. So we have C. Miller's credential both as NTLMV1 and NTLMV2. So what does that mean to us? That means that I can crack either hash that I would choose. So I would go ahead and choose to crack the NTLMV1 hash over V2 because of speed differences. So in this example, in both screenshots, I obviously know the password for C. Miller. So I went ahead and created a hash cat mask, which is what you see right here. So it begins with a digit. Oh, I forget what it stands for. But I create the mask for that user. And then I go ahead and try to brute force that entire range. And you see that I was able to crack C. Miller's password in 32 minutes and 56 seconds. The NTLMV2 version of that password, it took me 7 hours and 43 minutes. And then the speed of the cracks are right here. 61 million hashes and 4 million hashes. Now, a really cool thing that I stumbled across so I guess a little context, pardon me. I gave a talk at a DoD conference, AvengerCon, sometime early last year, and it was on NTLMRelay and X. So I had done some research on this, and I was on a pen test, and I was running a responder, and I noticed this come across the wire. HVO1 $, so computer name, we'll call it high value 01. HVO1 $, authenticated to my machine using NTLMV2. And NTLMV1 and then host DC01 $, authenticated to my machine using NTLMV1 as well. So if I can crack this password, what that means is I have a computer account, and domain controllers by a domain computer account has the ability to run DC sync. So if I can crack this password, I have DA. The problem with cracking the computer accounts is that they can be massive in length. They can be, for some reason, I had 30 characters in my mind, but it's a more modern version of Windows use, I believe it's 120 or 200 character passwords and lengths. So you're never going to go ahead and guess it unless you use another service. There is a service out there called Crack.sh, which has, in essence, it started off being funded by EFF to be a DES cracker. But basically, they have a massive rainbow table where they can do brute forcing, but they have a massive rainbow table where if you can retrieve the NTLM hash with a certain challenge key, which I'll explain in a couple seconds, they have brute force the entire 2 to the 56 DES key space, which means that they can crack NTLM v1 hashes in 25 seconds, 99.5% of the time. Excuse me. If you don't provide this challenge key, this challenge code, they can still brute force it for you, but number one, it's going to be slower, and number two, there's going to be a cost. So Crack.sh cracked this password for free for me. So what I had to do was go back to responder.conf. I'm sorry, go back to responder and open up responder.conf, and I changed the challenge key, which is right here, from whatever random value was set or random variable it was set to 1, 1, 2, 2, 3, 3, 4, 4, up to 8, 8, just like the Crack.sh guide said. And lo and behold, there's my key. There's the challenge key, pardon me. And this challenge key, the NTLM protocol, when you travel or talk over a network, it's going to be unique. That's why if you ever ran Responder before, you'll notice that you'll receive the same password for this multiple passwords for the same user, because as far as Responder is concerned, each of them are unique password. But in reality, it's the exact same password hashed with a different challenge code. So here, not my forte, but we'll go ahead and cover it the best I can. So here we're using a script. It's all explained to you via Crack.sh's guide, but we're converting it from an NTLMv1 hash to an NTHash. And that very last line is what you're going to go ahead. You're going to do a direct copy and paste, NTHash and everything. You're going to copy that into Crack.sh, and then you're going to go ahead and hope it works. So I went ahead and I submitted it, and 31 seconds later, after I hit submit, or after my job started processing, it's password cracked. Now, the problem in this came that I simply didn't know what to do with this key. So the token was what I submitted to the Crack.sh. The key is what was brought back to me. So I assumed incorrectly that this key was the unencrypted password hash. Oh no, I'm sorry, unencrypted password for the hash I provided. I was incorrect. So I tried for a while. It didn't work out. So I figured I would go ahead and take a step back, and I configured in my lab environment, I configured a computer to use NTLMv1. I caught its hash. I followed the exact same steps, and then I tried that, and then I realized that the key was not the password. The key happens to be the NTHash of the token I submitted. So when I did that, I was able to get DA. Oh, I'm sorry, I was able to log into my machine, and then I went back to the client environment, tried a secrets dump using the DC computer account and the NTHash that I got from Crack.sh, and once again, I was able to do a DC sync and ensure get domain admin. Now, where have I gone wrong? So ATA is a phenomenal product. ATA is now Microsoft Defender for Identity. But so Microsoft has seen the trend of offensive security, folks going towards attacking AD. ATA is pretty much just set to monitor AD. So here are the 3 ways that I've been caught by Defender for Identity. Number 1, I mentioned earlier, when you do a secrets dump for a user, there's 3 kinds of hashes provided back to us. There's NTLM or RC4, AES 128, which is this bottom line, and then AES 256. AD environments these days only use AES 256. So if you choose to use the NTLM credential and ATA is being used, it's going to trigger a flag. Other ways Defender for Identity has caught me is when you do a DC sync, if the product is tuned, most organizations know what domain controllers they have. So they know that DC sync should only occur between those, let's say, 5 domain controllers. The moment the 6th computer attempts to do tries to do a DC sync, it's going to trigger an alert. That's why when you do a DC sync, depending on the client's reactions, you may want to do just BTGT, or you may want to do a user account that won't be a service account that won't be easily modified. So it kind of buys you enough time to persist in their network in case they go changing passwords. And then the 3rd way ATA has popped me is I created the golden ticket, and I did not. Mimikatz by default creates a ticket that will last for 10 years. No Kerberos ticket is supposed to last that long. I believe most tickets renew between 8 and 12 hours, and they expire after a few days. You have to re-authenticate. So my renewal time was not, we'll call it 8 hours. It was a little bit more. That was my fault when I created the ticket using Mimikatz. When my ticket went to expire, the ATA said, "Hey, wait a minute. This Kerberos ticket is not proper. we have an error here. So how do you avoid using NTLM or the RC4 flag, which would be the RC4 hash, which is the first hash from the previous screen? You use AES-256 with Mimikatz when you're creating your pass the hash or you're creating your PTT token. You use the ENC type flag for AES-256 flag for Rubius. And then if you're working from a Linux machine, you can use AskTGT. AskTGT is part of the Impacket suite, as is secretdump, as is NTLMRelay X. So you can ensure, you can tell your machine to go ahead and get a TGT from the domain controller. And then once you do that, then you can use the AES-256 key to do that. And then that way you don't have to worry about authenticating to multiple machines using the incorrect hash. So one cool thing of once you authenticate with AskTGT is now you don't have to use a password anymore. You have a Kerberos ticket. And it makes sense because that's how TGT works. When you authenticate into your AD environment, you are assigned a TGT. And then from that ticket granting ticket, you're able to request other tickets. So you're able to request TGS as part of ticket granting service. So when I want to authenticate to Steve's file share, I will get a SMB ticket for SMB service ticket for Steve's machine. When I want to authenticate via PowerShell to Patrick's PowerShell service, I will get a host type ticket to his machine. So same thing is happening here. We have our TGT because we did it in our previous screen, and now we're getting probably a SMB because there's a PS exact login, an SMB type TGS to authenticate onto that machine. So talking about little nuances that make my life a little bit easier with Responder. So Responder, you run it in a terminal window, and you might leave Responder running your whole entire engagement, which means it's pretty brutal to go ahead and scroll up. But that's what I did for a long time. For a long time, I went ahead and scrolled up in Responder in my terminal window, and God forbid my machine would crash at some point, or my terminal window would close, and I would lose everything. Then I became aware, probably by pure chance, that there was a logs folder inside Responder. So once you do that, you have all the traffic that's created in handy to catch log files. So here we have the Responder session log, the analyzer session log, but we also have the credentials for host 160.91.219.201, for example, and another host. Another cool little script is dump hash, which is part of Responder, which is what you see in the second screenshot right here in the bottom. And dump hash is an easy way to retrieve a list of all the hashes you've caught. So Bloodhound, I alluded to it earlier, but Bloodhound is an Active Directory mapping tool written by Andy and Rohan. So they go by Waldo and Captain Jesus on Twitter and in the Slack channel. So one cool trend that I've seen is that sometimes these tools get released in security conferences. So Bloodhound or I'm sorry, DerbyCon, or I think it was DerbyCon, but it might have been DEF CON. But they're kind of tied to offensive world because they get released at these conferences. But it couldn't be further from the truth. Bloodhound is a phenomenal tool, and I've actually seen more and more clients starting to use Bloodhound for defensive purposes, to the point where if you're involved in the government space, Executive Directory 2102 came out early this year and actually said, hey, go ahead and run Bloodhound to evaluate the configurations of your Exchange servers. Now, Bloodhound cannot tell you if it won't run a STIG check, or it won't do any kind of evaluation of the security settings of your Exchange server. But what it can do is it can tell you, hey, your Exchange servers are DAs. So if your machine gets popped, if your Exchange server gets compromised, and your ticket and they're logged into the machine and their account gets compromised, your whole entire domain infrastructure is now compromised. And they also went and said, hey, no admin of your Exchange in-house premise Exchange servers should have access to your Azure OWA web interfaces. So Bloodhound has become Bloodhound's really trying to be used by both sides to the fact that they came out with an enterprise version sometime this year, and that way you can do continuous monitoring of your environment using their tool. So the only thing I really want to talk about Bloodhounds are a few Cypher queries and how to create your own data set. So it is possible there's a tool called DB Generator, which is part of Bloodhound Tools, which allows you to create a blank, a totally non-customer tied database for use of Bloodhound. So this is great for when you're doing presentations, or great when you're just trying to learn how to use the tool. Because I can almost assure you that if you're doing an interview for a pen tester red team job, you will get asked about Bloodhound. So the key thing about this tool set is that you have to use Python 3.7. And the reason why I say that is when I was trying to do my screenshots for this presentation a few nights ago, I was not using Python 3.7. I was using Python 3.6. I got lazy, just did Python 3. And the tool was not working for me. So I went ahead and typed Python 3.7, ran DB Creator tool, and everything worked like it should have. I've also had problems on other attempts. So what I've had good luck doing is simply modifying some of the default values. So there's a value you can use to set the domain, which is set domain. So I set mine to BSidesNoVA. Set nodes, how many computers you want to have in your environment, or how many users you want to have in your environment. I changed it from 500 to 1,000. I type generate, and then lo and behold, it creates a database structure for me for use in Bloodhound. Which is also cool is that it creates different configurations, so you can go ahead and try looking for different things. It's pretty hard to read, but the third line from the bottom says marking some users as Kerberoastable. Great, we're going to use Kerberoast on most pen tests. It goes ahead and modifies some access control entries, which are basically ACL terms, and ACLs for AD. So you can go ahead and try looking for different attack paths. So it's a very cool tool to use when you just need something to show to a customer, or to spend some time working on your own with non-actual client data. So this screenshot is the only screenshot I will show you of the actual Bloodhound tool. How it works these days is you use SharpHound to collect data. SharpHound is the executable that will go out and query your AD servers, your computers, and retrieve back a bunch of JSON files that you can import into Bloodhound. Oddly enough, SharpHound is now considered a virus from Defender. So you go ahead and you import your JSON files into Bloodhound, and you can start going and navigating the GUI. So what I want to show you here is that what I tried to do was create a graph of all the users in the domain users at BSidesNoVA group. There was 1,000 users in this group. So Bloodhound says, hey, are you sure you want to go ahead and do this? Not only will it take a long time to run, but the graph is going to be pretty useless because it's going to be minuscule and it's going to be really hard to tell what's going on. So, excuse me. So what you can do is, instead of connecting with the Bloodhound client, you connect to the Neo4j server, which is the backend database for Bloodhound, and you connect to 7474 via HTTP. Once you authenticate, you can run raw Cypher queries on your machine, in the web interface, and you can return data in text format, so minus the GUI. So here we're running the equivalent to what we saw, what I tried to do in the GUI. What I'm saying is assign all the users to a variable of U, all the groups to a variable of G, and then where the group name is equal to domain users at BSidesNoVA, return the U.name, U being equal to the users. And you see that we get like 1,001 users back. The cool operator I use quite a bit is type. So in this case, it happens to be type R, but R is arbitrary. And I'll explain it once again. So we have G for group. So assign all the groups to variable G. And the permission I am looking for happens to be get-changes-all. Set that to R. Set the value of D, say the domain as value D. And then return the group names and type R being equal to the relationship. or I'm sorry, they call it edge type. Edge type is the correct term. So what we see here is group name, domain controllers. So domain controllers can have get changes to all permissions. For this example, not really a big deal, but imagine trying to document all the ACEs, all the access control entries that user Dan has, and Dan has 50 access control entries you want to go ahead and save. Doing it this way via the Cypher, instead of trying to go into Bloodhound and doing everything manually, this will save you, tens or an hour of your time. So I use Typar quite a bit. And once again, a quick sales pitch to Bloodhound Slack. They're there to help. You'd be surprised how much help you can get for your Cypher queries on that channel. So really worth going, checking it out if you're not there already. So other things, leaving the whole Bloodhound NTLMRelay X talk behind us. We have how many times have you forwarded a shipped out computer to a client and realized, oh crap, I need to install this Python library, or I need to install this utility, or I forgot to run apt update. I do it probably fair amount of times. So what I used to do is simply create a SOX proxy. So I would go ahead and log into probably my jump box, which in this example is SSH1, as Oaktree, which is me, and then log in, create a SOX proxy on port 9050, and then I will utilize proxy chains, the script, the tool proxy chains, to take all my apt update traffic and go ahead and forward that through the whatever configuration proxy chain has, which would be localhost 9050. So it would enter that SOX proxy on 9050, get forwarded out to the SSH server host, and then from there it will go outbound to wherever app update has to go. You can do it that way, or you can simply modify your app configuration. So you would add a file called proxy.conf for whatever file name you want to give it to your app config, and then you would add the bottom bullet to that file with the server and port matching whatever you need it to be, probably localhost port 9050 if you're setting to default, and then now you can just do apt update. I find the bottom one a little bit cleaner, but I've only known about it for about a week, maybe 2 weeks, so I can't say I use it very often. dnSpy. dnSpy is a really good application for looking at C# DLLs and C# executables or assemblies. If you happen to find yourself, quick note, if you happen to find yourself on a web application pen test, which is written in C#, or using Blazor, for example, or written in C#, you can pull down all their DLLs onto your machine. Use dnSpy and look at the source code being used by the application developer for the web app. It wasn't a huge find, but doing this, we were able to find the sanitization that the customer's application we did recently was doing. It didn't take us very far, but we were still able to see their source code. What we see here in the screenshot is simply one of my harmless C# scripts that will go ahead and add a user to local users to a computer local user account, and then promote that user to administrator. But this can be done with any executable using dnSpy. So dnSpy, the debugger / .NET assembly editor, and open source. Autoruns. Sometimes we get asked to do pen tests to evaluate the security of a gold disk, where we're given a gold disk for a gold image for a client. Either what we roll out by default to all our users, what vulnerabilities can you find on a local machine? There is a tool called Autoruns, which is part of Microsoft's SysInternal suite, which will go ahead and list out all the auto start locations of that machine. So it looks at the run keys in registries. It looks at anything Explorer starts up, IE starts up, scheduled task, services, WMI, and a few other ones. If you're on the offensive side and you're trying to find ways of persistence, and you can use Autoruns to kind of double check your work. If the SOC finds me on a machine, will they be able to use Autoruns to quickly identify how I'm hiding on their machine? Procmon, if you're ever curious what your machine's doing and you have administrator permissions, Procmon will tell you everything. It will tell you registry keys being used, files being written, network traffic, I think CPU utilization, but a couple other things. But it's a pretty chatty program. So what we're seeing here is simply a simple filter that I created for the screenshot, where we're looking for create files. We're looking for any files that have DLL in the path name, and the result is name not found. This would be the first step you would take in looking for a DLL hijack. In reality, all these files really aren't DLL hijack opportunities, because Windows has a particular search path that it looks for when it looks for files. So these files right here, cryptbase, win, mm, and I believe even version DLL are all Windows files which are going to exist in C Windows System 32. So if you go ahead and put your WinMM in Google Chrome application, it's not going to find it because it's already resolved somewhere else because of the search path. But this is kind of the first step to doing a DLL hijack. Process Hacker. Process Hacker is a simple tool to do to monitor processes running your machine. What I'm showing here for the screenshot is how to do. I was on a pen test and I was getting caught by AMSI. I forgot that C# also has AMSI support nowadays. So not only can you have to worry about your PowerShell code, but also your C# code. Kind of why developers are going to C++ and back this, or to C++ and C. So I was talking to Jimmy. Jim was giving me a hand, and he was like, "Hey, does the process you're trying to inject into have AMSI?" Fire a Process Hacker, and lo and behold, it did. So that's why I was being caught. Mimikatz AV Evasion. This is more of a sales pitch, gentlemen. This is a video from IPSec on YouTube. He puts out videos on Hack the Box videos. This was great for me because I can't tell you how many years I spent trying to wish I could make a version of Mimikatz that could bypass Defender. I always thought it was as simple as Control F, replace Mimikatz to kitty cats or whatever code you wanted to, hit enter and hit go. But it was a little more involved than that. But what I've learned from that video, I've been able to use quite often for other tool sets. It will help you get a bypass Defender. It will probably get caught by every other product, whatever you create. But that's usually enough for me. So Net-Obfuscate, we're trying to obfuscate C# assemblies. So once again, we're trying to bypass Defender. We also do training and lab environments. So we were trying to do a ransomware demonstration, but our ransomware assembly kept getting caught by Defender because we used Ryuk, I think the string was, and we couldn't modify it. We couldn't bypass Defender. We couldn't disable Defender because of real-time tamper protection. So we ended up just simply using Net-Obfuscate, which is an open source product tool, to obfuscate our assembly, and that was enough to get us bypass Defender. And then a quick comparison: I ran Net-Obfuscate on the C# assembly I wrote for add a user. You can see on the left is the original, on the right is the obfuscated one. Really, this code base is pretty simple, but what you see is it used a lot of base 64 to try to bypass, to try to obfuscate my code a bit. Now, the reason why I wasn't trying to knock on Defender is, the reason why I say we can bypass Defender is because there are tool sets out there which allow you to test directly against Defender's rule base. So there's a tool called Defender Check, once again available on GitHub, which you can run your binary against and see where it flags. So in this case, I went ahead and ran Defender Check against Mimikatz.exe, and it tells you exactly the byte offset to where it's being caught. So from here, you can go refer back to IPSec, or refer to IPSec's video and see what it recommends you do, which is basically break down your binary into smaller chunks around that byte offset. Find that code, figure out what code is triggering it, go to Visual Studio or Visual Studio Code or whatever you use to edit your code, modify it there, recompile, run against Defender Check once again, and kind of rinse and repeat until you get bypassed whatever product you're trying to get past. And sorry to rush through the very last couple slides. I told Daniel I would be done in 15 minutes, and I'm here at 55. Contact information, love to stay in touch, even though it's all virtual and I couldn't see any of your faces. Feel free to email me if you have any questions at all where I could be of help. There is my work email. On Twitter, I am Oaktree__. I am on Hack the Planet as well as our entire TGS team. As I'm there as Oaktree, and Bloodhound Slack as Oaktree. And that's it. Are there any questions that I can answer?
All right, thanks, Octavio. That was really great. We do have a couple questions that came up in the chat. One of them is there a consolidated list of some of these tools that you can reference?
No, but if you give me maybe till Monday, I can put something on my GitHub page and tweet it out.
Excellent. And for another question, once you leverage AD to create a machine account, is it more advantageous to do Kerber roasting or ticket attacks, since a lot of these defensive tools you mentioned are flagging the AS rep roast from non-machine entities?
Kerber roasting will also get you caught too. If you go out and try to query if you go ahead and query your entire domain blindly for any accounts that have SPN, ATA will capture you there as well.
Got it. And is Cobalt Stripe still your C2 of choice?
Yeah, it is. It is.
Excellent. Do you use a particular pen testing distribution like Kali Linux, or are you starting with something and building on top of from vanilla?
No, we use I use Kali a lot, but I'm not afraid just to use Ubuntu. Yeah, I mean, you really can get by with such a minimal tool set. If you're familiar with if you can do proxy tunnels using the TAC V flag, you can really get whatever tool that you need, but usually Ubuntu. Your answer is Kali or Ubuntu, but primarily Kali.
Got it. And what are, in your testing, what are some of the most effective defenses that kind of shut you down right at the beginning that you've seen, either tools or configurations, aside from some of the stuff you went over?
I mean, SMB signing. You want to stop someone blindly going into your environment. SMB signing, making sure NFS shares and SMB shares are limited to particular users, or at least limited to users or particular computers. Usually the two ways that we get onto a machine would be SMB shares. SMB shares. So we find credentials there, or we put malware, we put our code onto there for executable, or SMB or NTLMRelay for SMB signing.
Got it. And our last question is, with the big migration of companies to AWS or Azure AD, do you see that impacting any of these techniques, or needing you to use new techniques for those environments?
There's already been a migration of these tools for AWS. There's Dirk John, the guy I mentioned at least 3-4 times in this talk, has some new tool sets coming out. The folks over at NetSpy are doing some research on Azure attacks. There are books available for both Azure and AWS. And Bloodhound does have AWS integration, Azure integration as well. So while there is obviously the move to cloud-based, so is this tooling. There is Sentinel. I've heard mentioned about Sentinel in Azure being quite the challenge of the product to go against. So that's, I guess, something I have to be aware of.
Got it. All right. I think that's it for the questions, Octavio. So we really appreciate you coming here and talking to us today. Thank you.
Thank you. Thanks, Dan. Bye, everyone.